Այսօր խոսելու է Mars 2020 ծրագրի մասին, եթե որոշներ տեղյակ չէիք, չեմ կարծում, ինձ թվում է մեծամասնությունը գիտի, թե ինչ է իրենից ներկայացնում այդ ծրագիրը 2020-ին NASA-ն ինչ է ուզում անի։ Կարևոր միշն է, որի մասին ավելի մանրամասն այս մի ժամվա ընթացքում Ելենան կներկայացնի։ Եթե հարցեր ունենաք, Ելենան անգլերենով է խոսալու, եթե հարցեր ունենաք, խնդրում եմ ուղղակի բարձրացրեք հայերենով, մենք կթարգմանենք, եթե պետք լինի։ Լավ, սկսենք։
Hello, everyone. As mentioned, my name is Elena Samerjian, and I am a NASA JPL Solar System Ambassador. I work for the Jet Propulsion Laboratory, which makes the rockets that fly to space. My major is theoretical physics, so I deal with I imagine the problems that later engineers have to put into place. So today we're going to be talking about Mars 2020. Mars 2020 is the first mission from NASA that is sent to find life. The past missions have been to find, the first was to see if there's organic molecules and compounds that are suitable for life. That was the first missions. The second missions after that, the point was to find water. And now that we've found both what's needed for organic life and also water, now we are on to find life. So at the end, there is going to be a website where you can, students K through 12 can go online and name the NASA rover, because the Mars 2020 rover does not have a name yet. So, over հետաքրքրված առաջի դասարանից միջև 12 դասարան high school եւ elementary school student-ները իրանք կարող են գնան online եւ essay գրեն, որ տեսնենք բանը իրանք անուն պիտի տան rover-ին ու այդ ձևով մեկը կընտրվի եւ ոնց որ կիմացվի որ դու միջև վերջ բանը history-ով որ դուք եք name արել Mars rover-ը. So to start 25 տարի առաջ, 25 years ago, NASA launched the Mars Exploration Rover. The goals were to find out if life ever arose on Mars, to characterize the climate of Mars, characterize the geology of Mars, and prepare for human exploration. Orbiters and rovers. We began Mars exploration with orbiters, which were satellites orbiting around Mars. Driving a device 225 million kilometers away from Earth is no easy task, so if we eventually landed on Mars and began exploring the surface with our now famous rovers, which the Mars 2020 rover is going to be. As advanced as science has gotten, computer power on board is limited, and that is because of all the radiation that's in space. So as complicated as the rover looks, it has as much electronic power as your cell phone does. This is the history of past NASA rovers. The Viking 1 is the one that found carbon. The Viking 2 was in 1980, and combined, these two Viking orbiters returned the first 50,000 photos of Mars. And later, we'll see the first photo of Mars ever taken. The Spirit rover went for a 3-month mission to look for signs of water on Mars, and it lost communication in 2010. Opportunity rover in 2013 investigated the Endeavour crater. The Curiosity rover launched in 2011. It suffered a mechanical problem while exploring the Gale crater, And the mechanical problem was with the drill. So the drill is taken offline, the drill doesn't work, but it's still operational. So it went for a small mission, but it's been extended. So far, what we have discovered on Mars. We have discovered methane, how it migrates. We've discovered dust devils, which we will watch the video of the dust devils later. We have discovered that it used to have a magnetic field. And a magnetic field is what Earth has that protects life. It's from the core. The core, we have an iron core in the middle of the Earth that spins and conducts the magnetic field. So the magnetic field makes it so whenever the sun sprays, that it doesn't penetrate and it sloughs it off. So the auroras that you see in the northern lights, that is actually the sun and our magnetic field coming into contact with each other. We found that there is liquid water under certain conditions, and there are all the raw materials needed for life, which is sulfur, nitrogen, phosphorus, oxygen, carbon, and hydrogen, but it is about 90% carbon. The Mars 3 Soviet lander is the first man-made lander that was on the surface of Mars. It transmitted data for 14 seconds in December of 1971. And over here you can see all of the missions from all of the countries on Earth that have gone to Mars. We have America, we have the European Space Agency, we have Russia, the Soviet Union, China, and hopefully one day we will see Armenia's flag up there as well. Go ahead. Found it. Oh, great. Is it working? So this here is the first image of Mars that I was talking about from the Viking lander in 1976. These are our previous landing sites. So this is where Phoenix, Viking lander, Pathfinder, Opportunity, these are the places that we have landed and explored around. So we're always building on the weaknesses of the predecessors. One thing that we found is no matter how much money and testing we do here on Earth, things can go wrong up in space. One of the problems that we have innovated on are the wheels. Some of the things that have been happening, because we don't know the actual terrain, it's a mystery until we get to explore it, is the wheels. Sometimes they get stuck in the mud. Sometimes they're punctured by rocks, especially on Mount Sharp. Curiosity had problems. So one of the innovations that we need is better wheels, things that can survive. And we actually have a new technology, which is helicopter technology, which we have implemented for the Mars 2020 rover to save our wheels for wherever it's safe. Over here, as you can see, it's about the size of a person, and this is on purpose. It's about 5'4", 5'5", and that's so the pictures are seen from a human eye level. So for public relations, it's almost like you're standing on Mars and looking. Oh, that's a little small. So there were 3 potential landing sites. It was the Jezero crater, which filled and emptied repeatedly by a lake for nearly millions of years. It was Sirius Major, which was covered in water and volcanically active, which means there's warm water over there, which is better for life. And the Columbia Hills, the Gusev crater, that's where Spirit confirmed evidence of liquid water. Recently, we have gotten news from NASA that we have picked the Jezero crater. So the Jezero crater is where Mars 2020 will ultimately be landing. And here it is. This is exactly where the Jezero crater is, and that's where the next images will be coming from Mars 2020. Right there. So this is our launch and landing. It's launched with an Atlas V rocket made by Lockheed Martin. It's going to be launching in July of 2020 and landing in January of 2021 from our Cape Canaveral, Florida base, where most of our rockets are flown. So our rockets are made in Pasadena, California. Our control station is in Houston, Texas. Our launch is in Cape Canaveral, Florida, and our headquarters is in Washington, D.C. And our satellites that receive information are in Barstow, California. Our landing, we have actually perfected. Before, we used to use the bounce technology. So we would cover it in a balloon type thing. We would drop it and it would bounce, and eventually the parachute, the air would be taken out and then it would open up. But that was not a very precise landing. So now what we've done is thrusters that hover down and cables come down, land it. Once there's some slack, the cable is cut and it flies away. So that is what we see over here, the thrusters, and it lowers it down and then it flies away. And it's called the sky crane method. And the thruster is actually programmed to fly 600 miles away, and that's so it does not crash into the rover. So these are the engineering marvels of Mars 2020, and these are the instruments that are going to give us the information from the Jezero crater. We have the Mass-Z camera, which is basically the public relations, what the public is going to be mostly seeing. And it's 360 degrees. It's going to be panoramic, 3D with advanced zoom. We have SuperCam, which is a participation from France. It's a spectrograph which can analyze the chemical makeup 20 feet away using a high-powered laser. We have Metasensors, contribution from Spain. It is a weather lab. It analyzes wind, temperature, humidity, and dust. RIMFAX from Norway is radar imagers. It sees tens of meters below ground and ice caps. We have Pixel that tests rocks finer in detail than ever before, down to a grain of salt. And it's looking for microbial evidence, because if there is life, it's probably not the size that we are. It's probably microbial. That is the hypothesis. We have Sherlock, which is UV light, in searching for biomarkers. And it's also looking for materials for spacesuits. So to know how to survive on Mars, we have to find materials that already survive on Mars. So we're going to be testing different materials, and from those materials is what we're going to be making our spacesuits for human exploration. My favorite instrument is MOXIE. MOXIE is going to be the first artificial tree on Mars. So what MOXIE does, because the atmosphere is mostly carbon, like a tree takes carbon from the atmosphere and puts out oxygen, we are going to be making oxygen from carbon. So in this way, we're going to start the first steps of terraforming Mars and making it habitable. And here are the different instruments. If you guys are interested, you can Google these different ones. And as you can see, there are different countries that contribute. So I hope, just like the flags of the past, I hope one day we can have a contribution from Armenia. And the way that we can do that is you guys can get in contact with NASA or Caltech and ask what are some problems, like I said with the wheels and some other things. Ask them what the problems are. And if you guys are interested, put together a think group, an idea group, and fix those problems. And go to NASA and say, we heard you, we know that these are your problems, we want to make a contribution. And just like they did, you can have your flag, your name, and a partnership with NASA on a future mission. So this is our deep space network. The satellite that I was talking about in Barstow, California is here. That's where we get all the information from our satellites. So the rover sends it to the satellite sends it to us, and then it's a back and forth. So this is called the Deep Space Network, and it travels by the speed of light. So it's 4 minutes from Mars to Earth, so there's always going to be a 4-minute delay. Just like there is an 8-minute delay for between us and the sun, so it takes 8 minutes for light from the sun to get to Earth. So this is our Mars 2020 helicopter technology. Later on, I'm going to be showing you guys a video of what the helicopter technology actually does and how it works. It's almost like a drone. So because of the wheel problems we were having, we decided that since we can't make better wheels, we are just going to fly around and not even rove as much. So we're going to keep the rover in safe places, and we are going to be sending out the helicopter to do imaging. So it's the first use of helicopter technology ever to be used on Mars, and it's powered by solar technology. It's by solar power. Samples will be collected by the rover, and it's going to be stored in tubes and dropped in specific coordinates. So all of those instruments, all of the materials that we're going to be doing, we're not going to be sending it back immediately. What we're going to be doing is we're taking the samples. There's specific coordinates. We're going to drop the samples in those tubes, and a later mission is going to go pick it up and send it back, and then we're going to be testing it into our labs. So we're not going to be getting the actual materials as soon as we hope we would. So here are the dust devils on Mars. This was photographed by Spirit. And these dust devils are like little tornadoes or little dust storms that you would see in like the deserts of Nevada or the Sahara. And they're not very powerful, they're not dangerous, and what we have actually discovered is that they're very useful to the rover. What they do is they come and they clean the rover. So the solar panels get cleaned every time the dust devil comes by, so we can make more energy and power. So we are very thankful for the dust devils. They're actually angels. This is Earth from Mars. This is what we look like. It's almost like a star from Mars. So you're looking at yourself. This is a picture of you. And this is a sunset on Mars. This is how it looks on Mars because it's farther away from the sun. You get this image over here. This is where you can go to name the NASA rover. It's go.nasa.gov/name2020. I'm going to be showing you guys the different videos. Over here, you can see the dust devils coming past. And here they are. And they're a result of the sun warming the ground. This is our helicopter technology. This is what happens where I work at the NASA Jet Propulsion Laboratory. We test the instruments before we send it off. And this is sunset on Mars. So that concludes our presentation on Mars 2020, and I'll be taking some questions if you guys are interested.
My name is Gabriel. In regards to the helicopter technology, when you guys are testing it, do you guys supply the same type of environment in regards to like atmospheric pressure and this and that? So everything's, yeah.
Exactly. We try to make it as close as possible because we don't want to spend all of this government money, taxpayer money, and have any room for error. So with the rovers, we actually do it in Nevada, where it's most like Mars. And then we try to make it as close as we possibly can, but because we've never been to Mars, and we're still learning so much about it, it is so difficult to actually get it right. So there's always going to be a big room for error until we actually know what's going on there. Good question.
Ուզում եմ հարցնեմ, իր էներգիայի աղբյուրը ո՞րն է։
What's the energy source of the rover, Mars 2020?
It's solar powered. So from now on, we're trying to do everything solar powered. So yeah, that's exactly what we're doing. So as I mentioned, the dust devils, when they come by and they sweep off the solar panels, it gives us more energy. So from now on, NASA is going for a more clean mission basis.
Արևի էներգիան է հիմնականում power-ը, հա, հասկացա՞ք։
So արևի էներգիայից ենք մենք օգտվում solar panel-ներով. Okay, you guys, I think we're good. Yes.
May I ask about liquid water on Mars?
Sure.
In 2018, there was a discovery that they found, due to the penetrating radio waves, they found a layer of liquid water under the polar ice.
Yes.
Under the surface, about 1.5 kilometers deep. And they assume that it is because there is some pressure from the that ice layer, that is why it can exist as a liquid water. So is there any project idea to penetrate that layer and to investigate?
Yes. So one of the instruments that I talked about that uses the high-powered laser to go 20 feet into under the ground, that is one of the things that is to discover life. So since we already discovered that there is water, we're thinking that if there is life, it's not on the surface, and it's underground. So these ice caps is exactly where we're going to be penetrating the radar to look down and find water and hopefully life.
I mean, penetrating not for radio waves, but for an instrument, for a probe,
Yes.
to penetrate the layer, go there and to investigate that water.
We don't have that. No, we don't have a drill. And one of the reasons why we don't want to do that is because first we want to observe from far away, and then have the scientists take time to understand how to approach it, because we don't want to mess anything up. Sometimes, you poke a hole and then you're like, oops, what did I do? I wasn't supposed to do that. So always when Osman երկու անգամ measure արա, մի անգամ կտրի, դա այդ ենք ուզում անենք, ուզում ենք երկար մտածենք, ոնց ճիշտ ձևով անենք, որ ամենաքիչ damage-ը անենք, որտեղ մենք նենց ենք ուզում անենք, որ մենք ստեղ չենք, բայց ուզում ենք իմանանք ինչա կատարվում. So ինչքան քիչ կարանք disturb անենք environment-ը naturally, տենց ենք ուզում անենք, որովհետև ոնց գիտեք, մենք արդեն in past missions մենք շատ space junk ենք թողել վերևները. So it's almost the second layer of Earth, all of the different satellites and the pieces that are flying around, and they're actually very dangerous to the new missions that are going. And they're dangerous to us because sometimes they can fall if they get too close and are sucked up by the atmosphere, and they can fall down to us. So we want to make sure that we don't do the mistakes of the past and just litter all over the place. So we want to be very, very careful, and that's exactly why we don't have a drill technology just yet for this rover.
Thank you.
Of course.
Excuse me, is there any mission about cleaning that space junk for the future maybe?
So that is a good contribution. Right now, there's some ideas of how to do it. Some people are saying we should take a net, some people, but they're flying so fast that even a tiny little piece is very dangerous at that speed. So right now, there's no set thing to do to make it so we clean it up, but that is a problem, a very big problem that needs a solution.
That's what Mimi. Thank you for the presentation, Ellen. And the question is, if I may, about your career path and how you ended up in NASA.
Sure. So a lot of people think to get into NASA, your whole life you have to be a space junkie and a nerd, and you have to be into math and science all your life. But that wasn't the case for me. I wasn't really into science when I was a kid because I remember this one thing that happened to me. I was in 3rd grade the first time I heard about space. I came to America whenever I was 6 years old. So I started 1st grade in the United States. In 3rd grade, we came into the classroom after lunch. Our teacher put down the projector, and she's like, this is the sun, this is Mercury, this is Venus, this is Earth, this is Mars, and then all the way, down to Pluto. And she's like, okay, memorize these words, the test is on Wednesday. And I remember seeing that picture of Saturn, and I was so scared. And I remember thinking to myself at 8 years old, okay, that was scary. We're not going to think about that again. And that was because I didn't understand. And that's basically how humans have always felt. We don't know where we are. We don't know who we are. We don't know why we're here. We don't know what this is. So that's a very scary idea. So as a kid, that was too much for me to handle, and I did not think about space for the next 10 years. Until I was graduating high school at 18 years old, I was sitting down on my balcony, and I was looking up at the stars thinking, what am I going to do after high school? What am I going to major in? What's going to be, what are my passions? What am I interested in? And then I was looking at the stars and the moon, and it was almost like I was seeing it for the first time. And a question popped into my mind. I was like, where am I? And I became obsessed. I went on YouTube and I searched every single video on space, on stars, on dark matter, on energy, on every single thing you can think of. And one documentary would lead me to another topic, to string theory, to fractals, to this, that. So basically, I self-educated myself, and then I started reading different articles, different books, and all of these things. But I started with YouTube videos. That's how I got into NASA. So go on YouTube and watch videos. And I'm a very visual learner, so it was very interesting to me. And while I was researching, I came up with a theory of how the universe works on a fundamental level. I wrote this theory, which became my PhD thesis. It's 4 forces and 2 resulting forces that make up everything in the universe. It's the unification and separation of opposing potentials of vibrational information. And that means that everything in the fundamental level to the micro to macro scale, it's made up of 4 forces. Everything is vibrations, is information, is potentials, is opposites, and it's the unification and separation of these forces that from atoms all the way to how universes multiply, because now we found out that perhaps that there isn't a universe, that there's actually a multiverse, which is M theory. So that is what I worked on, and what I did is at that time I was working in actually politics. I was working in the California state legislature. I was helping write a law for Assemblyman Mike Gatto to recognize Artsakh in California, which I'm very happy that we passed. And during that time, I was very busy with the bill and with politics, and my mom kept urging me to finish my PhD, to do my theory, and she told me, send it to NASA. So just to get my mom to stop bugging me, I sent my thesis to NASA. And surprisingly, I didn't expect any contact from NASA at all. What they did is they sent me a packet from Charles Olachi, who's the director, and he said he read my theory and he thought that I, was right and I had something there. So I interviewed and they offered me the position in 2016. So the cool thing about my job is that I get to go to every single department. There's, the department, it's a huge campus. Whenever people come up to me, they're like, oh, do you know this person from JPL? There's so many people in JPL. There's no way I could know all of them. What I do is I go to every single department. There's a department working on Mars. There's a department working on the Juno mission to Jupiter, Cassini's mission to Saturn, the Parker Solar mission to the Sun, and on climate and Earth science, and all of these different departments. And what I do is I go to every single department, and the head of the department tells me the news and what they want the public to know. I make the PowerPoint presentations and the speeches, and they send me out to different educational, academic, government organizations, and I basically give these speeches that you guys just heard. And so that's how everything went for me. So never think anything is hopeless. Like, always try, because if you don't try, it's still a no, right? So try.
Hey, thanks for your wonderful presentation.
Thank you.
My question is, are there any other countries who are planning to land on Mars besides European Space Agency that's like building its rover now?
Not that I'm aware of, no.
Okay, thanks.
But there might be.
Oh.
Great. Thank you, guys. You have been wonderful. I appreciate your time.
Thank you, Elena ջան, քեզ ենք շնորհակալ, որ ժամանակ գտար։ Իդեպ Ելենան վաղը թռնումա հետ ու տենց արագի մեջ որոշեց, որ անպայման պետք է այս իվենթը անի մեր հետ։ Տենց մերսի, շատ հետաքրքիր էր։ Okay. Հույս ունենք մյուս անգամ քեզ էլի կտեսնենք նորություններով, չգիտեմ, update-ներով։ Okay. Thanks much. Ձեզ էլ մերսի շատ։ Who wants a picture with Elena can come here. We can make a big group picture with her. Yeah.
If um, if I were a book.